Shapes and sizes. This topic is about questions about shapes and sizes, lengths, area, volume, things like that, compound shapes, and how we might rearrange equations to answer many of the questions that they typically ask. Before we do that, I want you just to put your head around something really very simple, but look at it maybe from a different perspective. Questions involving shapes and sizes use a number of equations for length, area, volume, all of which are given in the tables. So you don't have to learn any of this. Being able to rearrange the equation, though, is key, because they'll only give you the equation in one form, the standard form. I want you to consider the following numeric example, almost philosophically. It's so simple. So 2 times 3 is 6. And say, okay, I've done that a lot. 2 times 3 is 6. That's an equation because there's an equal sign. 2 times 3. But in that equation, there are actually a few other relationships. It's saying that if you multiply 2 times 3, you get 6. But if you were to divide 6 by 3, you'd get 2. If you were to divide 6 by 2, you'd get 3. So in that sort of 3-numbered sort of relationship, the relationship between can also be arranged as 6 divided by 3 is 2, and 6 divided by 2 is 3. In this way, there are 3 equations in that one equation. The first one is 6 is 3 by 2. 3 is 6 divided by 2, and 2 is 6 divided by 3. In each case, I've only left one number on the left-hand side. The relationships between the numbers can also be managed in a triangular form, where the top line, 6, represents the multiplication of the other 2. So imagine a triangle with 3 boxes here. 3 multiplied by, so that's a multiply on the bottom there. I'll just get a red pen. Let's get to use the same color. 3 multiplied by 2. On the bottom, 3 by 2 is 6. 6 divided by. If I've got 3 numbers there and I leave one of them blank, I can find it. Because 6 divided by 3 gives me 2. 6 divided by 2 gives me 3. And the multiplied 3 by 2 gives me 6. And you've seen these equations sometimes in physics. They might say something like V is IR or something like that in volts or something like that. That may be voltage, I might be current, and that might be resistance or something. Or there's other equations like that. But 1, 2, and 3. So for example, the missing number can always be found from the other 2. Where the missing number is on the bottom line, it can be obtained by dividing the number on the top by the other number. So if the missing number is 3, 6 divided by 2 is 3. 6 divided by 3 is 2. And if it's on the top, you multiply. So the rightmost number in the bottom line can be done by dividing, and the one on the top. So it's just the 3 are always together. Now, you might think that's an awful lot of fuss, for 2 times 3 is 6. Okay? And it is. But let's consider this one now, and let's consider an algebraic example. Very simple shape. We're talking about a rectangle, and we're saying that the area of a rectangle in square meters is given by the width by the length. This is standard equation. The area is length by width, or in Irish it's fad fá lehead. So we'll call it area is length by width. Okay? So length by width. Rearranging the equation, we note that the relationship between area, length, and width can be written as area is length by width. And we could write it like that and put the area on the top and the length and the width here. Length by width is area. Area divided by length is width. Area divided by width is length. And they're all fine. These 3 equations, though, 2 of them have 2 things on the left-hand side, and I like just to have one thing on the left-hand side. So in this case, I've got area is length by width, the first one. W, the width, is area divided by length, and the length is area divided by width. So you see exactly what's going on in that. Is that okay? You have only one equation in your tables. Not that you'll have any difficulty with the equations for a rectangle, okay? But in every equation in your tables, they only give you it in one form. So now let's look at the next one.